Just as the human microbiome is essential for regulating the health of the human body, the soil community across the globe is critical for regulating the health of our planet.
Since this was a review, we sifted through hundreds of pieces of previously published scientific literature in order to generate a better understanding of the distribution of soil biodiversity, as well as the distribution of soil carbon stocks worldwide.
We've all known for a long time that when you move from a grassland to a forest, we've got a completely different type of ecosystem. But what we found is that when you move from two different types of soil community, the impacts can be absolutely astronomical. So managing soil communities effectively can be an absolutely critical move towards sequestering more carbon and improving plant growth and food production for humans.
Whether it's bacteria or fungi or animals or protists, we find that the greatest diversity of life is found in the tropical regions. And what's so interesting about this is that soils are thought to be so complex and so diverse that there really shouldn't be any global trends. But by looking at all of the published literature, we're able to see these clear patterns that emerge. But possibly the most interesting thing that came out of this is this graph. And what it shows is the amount of carbon that's stored above ground in living plant material versus the amount of carbon that's stored below ground in soils and microbial biomass.
So we see that the accumulation of carbon on land is negatively correlated with the temperature of that ecosystem. That means in warmer ecosystems, we have faster decomposition by the soil organisms, and that means carbon is released more into the atmosphere. Which also means that in cold areas, we see this huge accumulation of undecomposed material.
This huge stock of carbon below ground represents a potential ticking time bomb. As the climate warms, these northern areas, boreal forest, Arctic tundra, they're actually going to experience the greatest amount of warming. And this can lead to what's called a positive feedback, where carbon is released into the atmosphere, it warms the soils release more carbon, which increases global temperatures even further. The other key aspect of our review is that we show, although the greatest diversity of soil microbes are found in the tropics, the greatest abundance of soil microbes is found in these northern regions as well. These really deep soils can hold much more microbial biomass. And so as the climate warms, these microbes are going to become increasingly more active. And as they become more active, they're going to break down dead organic material and respire this carbon into the atmosphere at accelerating rates.
So as farmers begin to use holistic management practices that promote long-term slow growth of soil communities, they will actually trap more and more carbon in that soil, with the potential to have huge impacts on slowing the rate of climate change.
Soils are fundamental to the global biosphere. They represent an enormous amount of biodiversity, they represent huge carbon stocks globally. And continuing to understand and reduce the complexity of these systems is really our best chance in fighting both climate change and biodiversity loss worldwide.
But ultimately, all of this research, while it highlights the value of soil communities for biogeochemistry, it also starts to reveal some of the most fundamental insights that we have into the distribution of life on our planet.